I thought you might be interested in seeing some things I found around Asia, some electrical things which are probably will give nightmares to professional electricians, and the rest of us should watch out for them in case we buy stuff from overseas. This item is probably the least scary. It's made by a reputable company, Panasonic National. The scary parts are the amperage on this switch. It's rated at 15 amps, 300 volts AC, and the plug is rated at 10 amps. Obviously no grounding on that. That's probably the scary part. These are still sold today. The box that it's in is rather flimsy plastic, and these tabs often break, leaving the plugs and switch hanging off the wall, exposing the wiring. There's hot points in here where you tighten the screws. I don't think you can see them. The screws are right in there. See the easy access to power right there. So yeah, not the safest item you'd want to see. The switch is rated at 6 amps at 220 volts. Kind of ordinary looking. Open it up, jump inside of it. You can see it's a little rusty, but these are the contact points here. Not much to them, not very big. And connection points, not great, not terrible, but 6 amps at 220 volts is pretty good power. Another switch also rated at 6 amps, 220 volts, has a glow-in-the-dark switch. Let me tear into this. Here are the wire attach points. As you can see, they're not very robust. One of these two brass connector points has a screw in it, like this, and that holds the whole thing together. When I turn it over this way, that's it. There's just this little mechanism, and the contact point is just a raised bump on a piece of steel, and the other side of the contact point is the screw that goes through to here. So the one brass connection here, wire comes in, power comes in, touches this piece right here, carries through to this connection, which touches that screw head right there, and comes out here. So that's your circuit. Yeah, not first choice. Here's a telephone plug, and why am I talking to you about telephone plugs and power plugs? Well, if you look at the end, they mount exactly the same way, and that is because many times you will find telephone jacks mounted inside the same box like this. They fit in the same size holes and everything as the power plugs. This is the modern style. The hole's a little bit bigger, but they make them in the old style, and they will go right inside the box, right next to a power plug, switch, whatever, and you oftentimes find telephone wires mounted inside of power boxes, and they're designed to do it. This is a plug from Asia. It's rated at 10 amps, 220 volts. This one actually has a ground on it, so it's not too bad, and it also has differing sizes between the live and neutral. I've mounted this on a transformer I used to go from 220 to 110 volts. But as you can see, it's it's not very robust. It's a very cheap kind of plastic, and they break easily. They very easy to access the insides by taking the screw out, and this one again is grounded, which is very unusual. This thing is rated at 15 amps, 250 volts, and this is a real hard stopper. This probably is one of the most dangerous things you want to see. This is a flexible plug, and it seems like a good idea because you can kind of put it behind a piece of furniture and plug it in the wall, and it doesn't have many issues. But you can see right here that it's not really very strong. The contacts move, and if we open it up, you'll see there's a nice crack right there, and just behind that crack are the contacts, and these are just kind of, it's kind of like a copper rivet in there that connects the legs. So the legs run up to here, they're riveted onto these pieces, and then they go to the wire connections. And no, there's no ground, and a little bit of water seeping through there would be extremely dangerous. and they also break quite easily. These things pop out of here. You got a lever, and if you're prying on them and they jam, which they do, this case will just break in your hands, and you'll end up with live wires in your hands. This is their equivalent of the wire nut. You slip wires in each end and tighten the two screws on top, and you have a connection. Come in various lengths. You can cut them off to whatever you need. And so, for example, this one's been done for neutral, live, and ground. And yeah, that's you say, well, that doesn't look too terrible. The problem is that the plastic is really cheesy. It turns hard, especially around fluorescent lighting. It'll turn hard and crack off of there. And then what you've got left is you've got this inside piece, this little brass piece exposed. The other problem is these screws are not that well covered. I mean, you've got hot, live brass and metal around inside here. It's very easy to stick something, a wire, a screwdriver, anything around inside the socket, catch one of these, and yeah, you're live too. Another issue is that as you tighten the screw, let me get a close-up of this. As you tighten the screw up here on top, it presses down on these wires, and it's very common for this piece of brass here on the bottom just to split all the way down. So you've got, it just cracks open, so you've got a very poor connection, and you can get arcing and heat and whatever in there. And at that point, this plastic is not flame proof. It is not anything proof. It burns, it heats up, it melts, it does it all. Here's one of the bigger sizes. Unfortunately, I don't have one with a plastic on it, but you can compare the insides. You'll notice that the bottom down here isn't that much thicker. This is made for some monster wiring, and you can get heavy-duty power at 220 volts flowing through here, and if this thing splits, get a bad connection, arcing, heat, whatever. But yeah, at first it seemed like not a bad connector, but in the end it doesn't work very well. Oh, and one other thing. Heating and cooling cycles often cause these screws to loosen. They also use wire nuts in Asia. They make wire nuts in Asia, and these two, one of them is from Asia, one of them is from the US. I'll let you guess which is which. And let me show you the difference here rather quickly in how they function. So here's our two pieces of wire we wish to join. We take our wire nut, put it on here, crank it on there. Nothing unusual about any of this, right? You notice the wires aren't twisting together? That's the first thing. Second of all, it doesn't want to, because this nut is made out of like a polypropylene, and it has a greasy feel to it. And if I can get it to do it, no, this is not going to do it for me. You notice it doesn't twist very much, and the cuts in here are not, it's more like scratches than they are cuts. Here's what's inside of that wire nut. It's just a spring, and it's just literally an ordinary spring. If you look at a American wire nut, you'll see that the edges in here are very sharp. The wire is squared off, and the edges have been sharpened like a knife. And so when you put it on here, it digs in. Not only that, but as you can see, this thing pops out. About 1 in 10 will pop out on you. So they're not well done. The other trick is, because the plastic is a rather soft plastic, it oftentimes will just come right out of the top. The wires will come out of the top as you start to turn it. Well, let's compare that to a US wire nut. First of all, let me just put it on there lightly. You can see the US wire nut begins to cut through the wire. It will cut through any oxide, whatever is on there, and it starts producing, you can see the grooves in it. It's not just a spring, it's actually cutting into the copper. And they're a lot tougher. They're better made. You can just, it's got a better feel to it. You can see it's twisting the wire already. These crowns are much deeper, much easier to grab. You put a lot more pressure on it, so you can get a good good connection. You can see right here on the camera I can do that without a lot of effort. And you can see it makes a nice twist, and again it cuts into the wire, so you get an outstanding connection here, and as it twists it you also get a good connection. So this is a comparison. The one on this side is the Asian one. You can see the spring is nice and shiny and whatever. It's just it's literally just a spring, chrome-plated spring. On the other side, the wiring is, and it's hard to tell, but the wiring has a sharp edge on it. The metal here has a sharp edge on it, and it will really grab a wire, really cut into it, as opposed to just kind of wrapping around it like the spring does. Here's a rather normal looking switch, but what's not normal is this. Goes up here, goes through this cement wall with no conduit, and is just strapped to the wall. Let me do a close-up on that. What you're looking at here are some aluminum straps. They look like this. They come in different lengths, and they are nailed to the wall with a little tiny cement nails. Don't have any of them. And then you wrap them around. You can see this. You wrap it around. There's the head of it. Wrap it around. Put the tail through there just like a belt. Fold it over, and that's your wiring. Most of the time it's not too bad, but when it catches fire it'll burn right up the wall. And it doesn't happen a lot, but for example, I've seen furniture pushed into one of these things when they're too low. Furniture pushed into it and crush the plastic and short the wiring, and yeah, start some sparks. This is a comparison of what they use for ceiling fan wire. The one on the right is from Asia, and this is a 14-3 from the US. It's quite easy to see that this is this 1.5 millimeter wire is considerably smaller than the US wire. Do you know what this air conditioner thermostat and this outside doorbell button have in common? They're both wired 220. Yes, there's 220 volts behind that switch. And as a bonus for today, this is an antique light bulb socket. You can tell it's a bayonet type. It's got 2 pins in the bottom, and this ring held on the glass globe. 2 wires come in there. You can tell they're very tiny wires. And we remove this. This is, like I said, a globe retainer. And then what you did to wire it was unscrew this ring. Yes, it's all brass. There's a ceramic piece in here with the 2 pins. I had to use some penetrating oil on it to get it to go. There's some spring-loaded pins in here like this. And you mounted this plate on the ceiling or wherever you're going to mount it. The 2 wires came through the wall, through the hole here. And then you stuck this thing up against there like that, with the wires coming through there. Stuck them into here. You can see this one's in there. You tighten them down with these screws here and here, and that electrified the socket. And then you screw this piece back on there, and without cross threading it, this is all very thin brass, you screwed that back on there like that. It should go on there. I don't want to cross thread her. There we go. Then you would put your glass globe over here, put on the retaining ring for the glass globe, tighten that down as needed, and put in your bayonet style light bulb. So yeah, quite a thing. But again, solid brass and ceramic. They really made them well. However, it's certainly not double insulated.